All right, so in part 2 here, we're going to look at doing a free body diagram not for the balloon, but for the spring. Okay, so again, do a box to represent the spring, not because it looks like it, but just because we just need something on a paper to represent that. Now, before we draw our vectors on it, let's list the things that are interacting. So interacting with the spring. What do you see that's interacting with the spring? Do you see the balloon? They're touching. That's obvious. Do you see the platform? Maybe that's a floor. I'm going to call it the platform. So the platform is interacting with the spring. And a third thing that's interacting with the spring is the earth again. Again, the name of that interaction is called gravity, but the objects that are interacting with the spring, the balloon, the platform, and the earth. Now what we're going to do is put these into our representation, into our picture. So, we do this, and this we can label force, earth, spring. So this is the force of the earth on the spring, or in other words, the interaction between the earth and the spring. Here, we're going to have force balloon on spring. The balloon pushes downward on the spring. Or another way to say that is that interaction between the balloon and the spring, that interaction pushes or is exerted downward on the spring. Lastly, we have the platform, and the platform pushes up on the spring. Force platform on spring. Now again, we have no idea about the relative size of these because these are three separate interactions. Platform spring, earth on spring, and balloon on spring. Three separate interactions. However, if we look up here, and we actually can see that we have the same interaction in this diagram as this. It's right here. Spring on balloon, balloon on spring. Those are the same interaction. So we actually know that that and that should be drawn to the same size. And if they're not, well, I can indicate they're the same size with a little tick mark or mark across the arrow. And that indicates that those two should be the same size. And again, they should be because they both represent the same interaction, the same force. Now, there's something else that... All right, one other thing we can do here. Sometimes it comes up, a question comes up like this. Do we need to draw these arrows down here? Well, the answer is no. We could say take this vector and its label, and instead we could put it up here. As long as it was on showing the correct direction of that force, we can put it anywhere we want. I guess that wouldn't work too well because then it overlaps the other vector there. But that's something that we could do. All right, or maybe it might be easier if you were so inclined. Maybe you think, well, the balloon on the spring, gosh, the balloon is on top of the spring. Shouldn't that be up on top pushing down? And the answer is sure, we can do that. We can put that up there like that. And that's okay because it still shows the proper size and the proper direction of that interaction between the balloon and the spring. So where we put the vectors on the box don't matter. They still represent the proper size of interaction and the proper direction of the interaction. These are some free body diagrams, and in the homework, I'll have you drawing some of your own.